Welcome. Thanks for joining me here today. So my name is Gautam Dhameja. I'm a solutions architect with Parity Technologies. And in the next 15 minutes, or let's say 14 minutes, 50 seconds, I'm going to talk to you about evolving blockchains, the blockchains that evolve with your business. And before we think about what they are, let me tell you what I'm actually going to cover. So I'm going to cover what they are, what are evolving blockchains and what I mean with them. Secondly, I would like to talk about why we need them in the first place, what benefits they provide. And finally, our new blockchain framework, Parity Substrate, how it enables them. So before we go into that, let's look at the problem of today. What we are looking at right now is when we create an enterprise blockchain, primarily a business blockchain, generally there is some sort of business process optimization using, putting the business logic on the smart contracts. Then there are some parameters to be tracked as part of this business process. And then finally, we connect a few systems to this blockchain so that those parameters can flow in. For example, in a typical supply chain blockchains, these systems could be inventory, could be payments, and so on. And finally, to make this data exchange between the blockchain and these external systems possible, we have oracles. So this is like a generalized setup of enterprise blockchain, no matter what platform you use. And what happens is, when you try to update these blockchains, or you want to make a small change in this blockchain, the first thing, let's say you want to do, or let me give you a simple example of that. Let's say a new, a member wants to join the blockchain, and they are bringing together with them some new parameters to track. For example, again, in a supply chain blockchain, a new supplier wants to join, and they want to add a few more parameters, and they want to connect a few more systems. What is the process behind that? What is generally happening when this upgrade needs to be done? So first of all, you want to update the smart contracts because there are new parameters coming into the system. Then you want to create the oracle for the new system to be connected to the blockchain. Then you want to migrate the smart contracts data from the old ones to the new ones, because that's how smart contracts work. You cannot change them. So you have to migrate the data. There are some patterns involved there, proxy patterns and so on, but when the data schema changes, you have to migrate. Finally, because there are so many moving parts, there are so many changes done already, you have to audit. You have to spend that money in getting things audited and then tested for functionality, for performance, and for security. And finally, you deploy with some new scripts because there are new systems coming into the picture. So this is like the process of actually upgrading or updating an enterprise blockchain. Pretty lengthy, pretty costly. And then finally, the entity joins the system. But what happens is a business process disruption. You are actually spending too much time and money on this thing that you are not able to focus on the actual thing which you wanted to do in the first place, which was your business process optimization. Well, that got disrupted. Sorry. So the conclusion is things change. And that's the only constant, as we know. But blockchains don't. So what do we do about them? And there are multiple different scenarios. This was just one of them when a partner was about to join a network. But what about there are new rules into the system? What about there are new parameters or new systems to be connected to the blockchain? All those scenarios actually go to the exact same process. And the hard reality is it's really, really, really tough to change the blockchains of today. Now let's talk about the cost, because we see a lot of projects happening in the blockchain space, but the ground reality of every project is that it is bound by a budget. Every project has an upper limit on a budget, and we have to keep our implementation in bounds. Now, if we divide the implementation of a blockchain, or any project for that matter, into three high-level phases, we first start with the build phase, then we go into the maintenance, we acquire some technical debt along with the time, and finally we rebuild. And if you see, most of the time when we estimate the implementation of a software project, we actually estimate the build phase. We never talk about the maintenance phase. And when it comes to conventional systems like simple distributed or even complex distributed systems, you can actually easily change the blockchain or change the system. You can simply go in, change a few things here and there, make some fixes, and then just go into production by testing. You do not have to do all that process that we saw in my second slide. But when it comes to the blockchain, when it comes to the maintenance phase of that system, you have to do all of those things. And that makes the whole process more costly. Each and every bug fix that you want to make, each and every process flow that you want to change in a blockchain-based system has additional cost associated with it during the maintenance phase. And this is actually the delta, which is huge. And by the way, let me give you a brief disclaimer here. These are not, real figures coming from somewhere. These are just relative figures being just for comparison. But if you understand the process of how software life cycle happens, this is pretty much, like this, that when you want to change something which can be changed, you have less effort. When you want to change something which cannot be changed and you have to go through the workarounds, you have to put more effort into that thing. And that brings the delta in the cost. Now, what we need to make blockchains upgradable, what exactly is needed for removing or reducing that delta in the costs. So the first thing is you must have a process or a governance process to actually make those changes possible. Because one thing, which is the ground reality of blockchains, is that blockchains are governed. They are not administered. There is no single admin. You need a governance framework. And you need to have an efficient one on the chain. Second thing is the system should allow upgradability from the design. It should not be like you are upgrading something which cannot be done later on. The third thing is you should be able to extend the framework as you wish. There are a lot of times you want to change the economics of the system. There are a lot of times you want to just change the consensus algorithm because maybe proof of work doesn't work anymore and you want to go to proof of stake or proof of authority. What do you do in that case? So there are a lot of changes that you want to make with time. And finally, every enterprise blockchain integrates with something outside. Blockchain is not the only solution. It's part of the solution. So it has to integrate with other pieces. So these are the 4 things that are actually needed, or you can say 4 pillars supporting the same roof of creating upgradable and efficient blockchains. And now I want to introduce our new software or blockchain building framework called Parity Substrate. So a brief of the history about it is Parity Technologies started with building the most efficient Ethereum client in Rust. Then we built the Rust implementation of Bitcoin. Then we built the Rust implementation of Zcash. And now we are building Polkadot. And while building all of these 4 blockchains, we realized that there are a few core components which can actually be extracted out and can be reused to build custom blockchains. So we created Substrate. And Substrate is completely open source modular framework for building custom blockchains. And what it provides with itself are a few set of characteristics which are not there in any other blockchain building framework for that matter. And I'll walk you through with all 4 of them. So I gave you a glimpse in my previous slide, what are those 4 characteristics. And now let's look at them in slight more detail. So first of all, on-chain governance. It is really, really hard to actually govern blockchains if you are not having any sufficient framework on the chain. There is one thing to do putting things on a Google Doc or on a paper that this person will join the network, these parties will be associated with the network. And there is another thing to enact those rules on the chain. And to make that process very sufficient or efficient for that matter, Substrate provides a collection of runtime modules to be reused directly in any custom blockchain. And these could be as simple as a council kind of voting scenario or a full-fledged democracy or a collective or a membership kind of thing. But you can do absolutely anything when you want to upgrade a blockchain using Substrate with these governance frameworks. The second thing is upgradability. Now, the most important and the coolest aspect of Substrate is actually upgrades without any hard forks. And this is something really, really new in this whole ecosystem right now, because any blockchain that you want to upgrade at the moment, I already walked you through the process. But in addition, what it does is it creates a hard fork on the chain. But here, you can actually upgrade the blockchain with Substrate without any hard fork. Because the whole of the runtime or the state transition function, which produces the blocks in a Substrate blockchain, lives inside a WASM blob. And it can be updated by a single transaction. So that's the beauty of it. So how it generally works, and giving you a bit of a brief detail into that as well, that actually the chain is smart enough to figure out which one is the upgraded runtime, and it will only use the new one. Now, because we are a little pressed on time, I'm actually moving a little fast, but let's look at the next one, is extensibility. So what generally happens when you create a blockchain solution, when you want to use a simple, framework from the existing ones, you download a binary, you give it a configuration as per your needs, and then you get a black box node running as a process on your server, on your system or something, and all you get is an API to actually call a contract or deploy a contract or something like that. And that's all you can do actually with an existing blockchain system. But what Substrate provides is something, a completely white box approach. You can actually go in and create your own APIs. You can create your own layer 1 runtime or the state transition function. You can actually create your own or plug in any kind of consensus protocol at runtime. So while the blockchain is running, you are able to switch the consensus engine. You can actually connect to external systems from within the node itself without affecting the block period, and that I'll come in the next slide. So this is like a completely extensible framework, more like a set of libraries which you can put together and create a custom blockchain in minutes. And finally, the most important pillar of an enterprise blockchain, integration with external systems. So this is how it looks like in a substrate-based blockchain. There is a concept of off-chain workers, which are actually able to integrate any system outside the blockchain from within the node. So there are basically two executors inside the node. One executor is doing your block production and moving the blockchain forward. And the other executor, which is also a WASM blob or WASM executor, is actually running your long-running tasks or HTTP requests or doing data analysis or anything which you want. So this can be completely configurable and changed at any point in time by doing the runtime upgrades. So this is like really, for that matter, saving costs in a way that you do not have to host any oracles or glue services or any of those things for your custom blockchains. You can do everything from the node itself, exactly what you want. Now, I gave you a brief about what was the problem. I gave you a brief about what we present as a solution as Substrate. Now let me tell you about evolving blockchains. So I'm going back to the exact same example. I have an enterprise blockchain. A new entity wants to join with new parameters and new system connecting. This time, the process looks this simple. We just simply upgrade the state transition function to include the new parameters. We integrate the oracle with the off-chain workers. We do not have to create a new oracle or anything for that matter. We just integrate the external new system with the off-chain worker. We do a simple runtime upgrade, and that's it. There are so less moving parts here. If you do not want to migrate the data, you do not have to. If you do not want to do the audits, you don't have to. You are simply just reducing the whole process of maintenance of a blockchain. And this is what we call an evolving blockchain, that when you want, how you want, you can upgrade it. And the most important part is, when you are trying to solve a business process optimization, you are able to do that without spending too much effort or time on actually upgrading and doing the housekeeping things. Now let's look at the cost impact of this thing. Now again, relative figures, but when the process steps become less, the cost becomes less because you are investing less man hours, you are investing less effort on those things. So the middle part, the middle curve is basically, the blue line is here Substrate, which is simply showing you that the maintenance cost of a blockchain-based systems built using Substrate becomes much, much less than a conventional blockchain. The build cost, like I say, both the conventional blockchain and the Substrate blockchains are starting from the same point. So when you are building a solution to create a blockchain-based whole system, these might look similar. But when it comes to maintenance, you are actually saving a lot of money, and that's where the major part of the system is. Well, thank you so much. I do have 1 minute left. I was actually initially not planning to take any questions, but feel free. One question. Yes, please.
Can you tell us which of those pluggable consensus modules you have which have at least some production use?
Yes. So we have the Aura, the proof of authority consensus algorithm in use. We are creating a new consensus algorithm, Babe, which will be used in the Polkadot framework or the Polkadot ecosystem. Along with that, a few teams community teams are working on a set of consensus algorithms implementations in Rust. So if you are able to actually follow an interface and implement a consensus algorithm, this can be simply plugged into Substrate. At the moment, we have 2 production ready.
Thank you very much.